All right. Um, so what we're going to do now is start solving quadratic equations. And we're going to do this by factoring. Now you're going to find out not too long from now that not all quadratic equations can be solved by factoring. So you're going to have to learn some other tools to solve these quadratic equations. But before we solve a quadratic equation, let's look at a very simple problem. And let's suppose I had this equation, 2x minus 1 equal 3. Now that's not quadratic. What kind of equation is this? Linear. All right, so how'd you solve this linear equation? So this, remember, is a linear equation. So how did you solve a linear equation? What was the idea behind solving a linear equation? Get the variable by itself, isolate the variable. So in this case, you would have add 1 to both sides, and I get 2x equal 4. Then divide both sides by 2. And so what's the solution? X is 2. All right, now what we're going to end up doing now is something like this. Suppose I want to solve number 2, and let's suppose number 2 was this. Let's suppose we had x squared minus 3x plus 2 equals 0. So x squared minus 3x plus 2 equals 0. Can I isolate the variable by itself? No. I cannot solve this one like I did this one. Here I can easily get the variable x by itself. Here I can't, because there are how many terms that have the variable x here? 2, and they're not all being raised to the same power. This is being squared, this is being raised to the first power. So knowing the kind of equation you're dealing with helps you to determine how to solve this. So this is linear, so we know how to solve a linear equation. This is quadratic, so you need to know that this is quadratic and your tools to solving a quadratic equation. For right now, this is quadratic. So right now, though, the only tool you know of how to solve this quadratic equation will be the following. Okay, so let's talk about something. One of the things you're going to need to know to be able to solve this is this idea. Let me go to another page. Suppose you had this. Suppose you're told that I have 2 factors and they're being multiplied together, and that product is 0. So A times B equals 0. So if I have 2 factors, and it doesn't have to be 2, it could be 2 or more, but for us it'll be 2 for the most part. If I have 2 factors whose product is 0, then what must be true about one of them? One of them has to be 0, right? That's the only way I can get a product of 0. So for example, 5 times what is 0? 0. 2 times what is 0? 0. So one of them has to be what? 0. So if A times B equals 0, then what that implies is that one of these has to be 0. So either A is 0 or what? B is 0. You're going to use this idea in these problems. Now this is called the 0 factor property. The 0 factor property. So the 0 factor property, notice factor, so your factors are A and B, and their product is 0. So the 0 factor property, and it basically says you take each factor, you set equal to 0. So before I go back to number 2, we're going to think about how to do number 2. Before I do that, though, let's look at this. So suppose I had this. Suppose I had, and I'm going to write this as number 3 for right now. Suppose I had this equation. I had x plus 5 times 2x minus 1 equals 0. Suppose I had that. X plus 5 times 2x minus 1 equals 0. What kind of equation is number 3? No, what kind of equation? An equation, a binomial is not called, an equation is not called a binomial. What kind of equation is this? Is it linear? It's quadratic. That's a quadratic equation. Because if I FOIL this out, which we did in a previous lesson, that was one of your worksheets a while back. If I FOIL this out, what's x times 2x? 2x squared. What's the outer? Minus x. What's the inner? 10x. What's the last? Equals 0. And when I combine like terms, I get 2x squared plus 9x minus 5, right? So this is a quadratic equation. It's actually this. But notice, though, this is what part of this? It's already factored. That's what I want you to say. Very good. It's already factored. So we factored this already. This is it. So I gave you the factorization. Now I want to solve this equation I'm pointing to. This is the equation I'm pointing to, which you know is factored as this. So how can I use this to find the solution to this equation?
Get x from each parentheses to other.
Wait, what? No, we don't plug in 0. Because, so you're saying 0 is the solution? And let's check it, okay? So she said 0 is the solution. She said plug in 0. What's 0 squared? 0. 2 times 0 is 0. What's 9 times 0? 0. So it's 0 plus 0 and a negative 5. Is negative 5 equal to 0?
No.
No. So 0 is not the solution.
You have to get x by itself from each.
So what is it you got to do? You're on the right track. You're just not saying it mathematically correct. What is it I've got to do? All right.
X plus 5 equals 0.
All right. So she's saying x plus 5 equals 0, but she's not mathematically telling us what to do, or why she's doing that.
Each factor is equal to 0.
What property allows you to say that x plus 5 has to equal 0? The zero factor property. So I have two factors whose product is what?
0.
0. And it's a good idea to denote those factors. What's my first factor? X plus 5. What's my second factor? What am I doing to those two factors? Multiply them. And their product is what? 0. Well, if that's the case, then one of them has to be what? 0. So when she says x plus 5 equals 0, what property is she using? Zero factor property. So basically what you do is, once it's in factored form, you said each factor equal to 0. So x plus 5 equals 0, and what's the other factor? And notice I went from a quadratic equation to what kind of equations? Linear. Now this linear equation, the one on the left, that's easy to solve for x. What's x? Negative 5, right? So x is negative 5. Over here, how to get x by itself? I got to first of all add 1 to both sides. And so 2x equal 1. Then divide both sides by 2. And so what's x? 1/2. So x is 1/2. So those are your two solutions. So there are two solutions. So notice that when we solved this linear equation earlier in number 1, how many solutions did I have? Just one. You're going to notice for the most part, it's not always true, but for the most part, when you solve a quadratic equation, you're going to have two different solutions. They're going to be distinct. Now, that's not always true, but most of the time it is what we're going to deal with. Now, let's check it. Let's check and see, just like we could have done here, I could have checked this linear one, right? So if x is 2, I'll go back to the original, and where I see the variable x, I plug in what? 2. So it's 2 times 2. 4 minus 1 is what? 3. So 2 is a solution. Do the same thing here. So let's check the fraction first. Now again, you don't have to check, because on a test you're not going to have time to do that. But in your mind, you can really think about it real quick. So if x is 1/2, I'll go back to the original. This was the original that was given. Not this, this. So x plus 5 times 2x minus 1. And I want to see if that's going to equal what? 0. So where we see the variable x, what do I plug in? 1/2. So I get x, which is 1/2, plus 5, times 2 times what? 1/2 minus 1, right? And I want to see if that's going to equal 0. That's the question. Well, let's look at the second parentheses right here. What's 2 times 1/2? 1. 2's divide out. What's 1 minus 1?
0.
So this is 0, right? I don't care what this is, although 1/2 plus 5, you know what that is. That's just 5.5. But what's 0 times 5.5? 0. So 1/2 is a solution.
Okay, excuse me. How did you find the 1/2?
I solved for x here. I added 1 to both sides, divide by 2. Solve this linear equation. Right? You get x by itself.
Okay, so the first part is 0. X plus 5 is 0.
You said each factor equal to 0.
Yeah.
And you solve the equation. Number 4. Let's suppose you had 5x times 2x minus 3 equals 0. Oh, no, we're going back. We're going to do number 4, and then we'll go back to, but thanks for reminding me. Let's do this one, and then we'll go back to 2. All right, so it helps if you know what kind of equation you're dealing with. What kind of equation is this? Quadratic. Because if I just use a distributive property this time, if I use a distributive property, I get 10x squared minus 15x equals 0, so that's quadratic. But the original problem was already in factored form. Now, technically, there are really 3 factors here. Because when I read it, I don't say 5x. I say 5 times x times what? 2x minus 3. So your factors are 5, x, and 2x minus 3. Those are your factors. So I have 3 factors whose product is 0. So that means one of them has to be 0, right? Well, usually though, what students tend to do is see this 5x, they leave it as 1. So they'll consider this as 1 factor, which is fine, although it really isn't. It's 2 factors times this. So let's say 5x then has to equal what?
0.
0, and then 2x minus 3 has to equal 0. So notice I went from a quadratic equation to 2 linear equations. So in that first equation, the one on the left, how do you get x by itself? Divide by 5. And so you found one of your solutions. One of my solutions is, one of your solutions is 0. Over here, isolating the variable, getting x by itself since it's the linear equation. Add 3 to both sides. I get 2x equals 3. And then finally, I divide by 2. So the other solution is 3/2. Now the 0 is easy to check. If you want to check these, the 0 is easy to check. Go back to the original. What's 5 times 0? All right. And what's 2 times 0 right here? And what's 0 minus 3? All right. So I have a negative 3 times 0, which is what? 0. If you want to check the 3/2, let's do that one by hand. So go back to the original. And where we see the variable x, you plug in 3/2. So I get 5 times what? 3/2 times, in parentheses, 2 times x, and what's x? 3/2, and whatever that is, I'm going to subtract 3, and I want to see if that product is 0. Well, let's do that parentheses first. What's 2 times 3/2? That shouldn't take you a long time to do, guys. What's 2 times 3/2? What is 2 times 3/2?
3.
3. What's 3 minus 3?
0.
And 0 times whatever this is right here, which is 15/2, is still going to be what? 0. All right, now, let's go to number 2 back. Now, think about what we just did and think about how you're going to deal with number 2. So remember, whenever you're solving a quadratic equation by factoring, you're using the 0 factor property at some point. So you're setting factors equal to 0. So when doing number 2, and think about what it is you got to use to get this to the solutions, what is it you think you got to do in number 2? Factor it. So that's the point now where you spend all of chapter 13 practicing factoring, and now you need to be quick with it. You need to be pretty good with factoring. Now this is the easy kind, so if I look on the left side, which is on your test Tuesday, the left side factoring, notice what's the GCF? It's a trinomial, right? So since it's a trinomial, you're going to go to 2 binomials. You're going to see if you can factor this as 2 binomials. And you can use either the AC method or you can use trial and error. It does not matter. So some of you are pretty quick at this. Some of you may take a little bit longer, but remember, you need to be fluent with factoring these. What do you think works?
X minus 1,
I'm just going to write what you're telling me. You just said what now?
X minus 1 and X minus 2.
X minus 1, X minus 2? All right, now before you go on, what some students do is they factor and they think what they have is correct and go on after that. You better check. It's real easy to check. All you do is check the outer and the inner for the most part. What's the outer?
2x.
Negative 2x. What's the inner? Negative x, 1x. When I add them up, do I get a negative 3x? Yes. So this is correct. Now, what's the next step, though? Remember, I'm trying to solve for x. I use a 0 factor property because I have 2 factors whose product is 0. So I said each one equal to 0. And notice I went from a quadratic equation to 2 linear equations. And each of these is easy to determine. What's x over here? 1. And what's x over here? 2. All right, now when writing the answers, when writing the solutions, so you're going to be given a blank. You can put the solutions. There are several ways you can indicate what the solutions are. You can actually say x equal 1, comma, x equal 2. You can say it like that. See what you have here? You can rewrite it. You could, if you want to, just say 1, comma 2. You could, if you wanted to, said this. Now, let me rewrite it. You could, if you wanted to, not say this. Don't say my solutions are 1, 2 in parentheses. You don't indicate your solutions. There's how many solutions here? How many solutions? 2. When you put it like that, you're indicating one of several things. That's a point, an ordered pair. Is this an ordered pair? No. But that's what you're indicating when you put parentheses, or you're indicating that this is an interval, and it's not. You remember on one of what was that?
You can put it either way. X equals 1, comma, x equals 2, or 1, comma 2.
Yeah, like that. But there's another way you could put it. So remember when the worksheet you turned in today, you had to do something with domain and range.
Mm-hmm.
What did you now? Remember, those were finite numbers. So you listed the numbers, but what else did you have to put? Not the bracket, but the braces. The braces. So that indicated a set, right? So my solutions is what set? The set of 1 and 2. Like that. Okay, so those are all different ways of writing the answer on the test, but don't put it in parentheses. All right, do not put that in parentheses. Now, in my math lab, let's see, on my math lab, they do this. They do, on my math lab, so it'll say x equal and then a blank, okay? It'll say x equal blank. And in the directions, it says use a comma to separate answers as needed. So in my math lab, you'll say x equal, and then what would you put? 1, comma, 2. That's how you do it on my math lab. Okay? Now don't put parentheses because you'll mark it wrong. You got to say x equal 1, comma, 2. That's how you write it. All right? Okay, so now let's look at number 5. So you have an idea now what to do to solve these quadratic equations by factoring. You got to use factoring. And what else you have to use after you factor? Zero factor property. So number 5, suppose we had 3x squared minus 5x equals 0. 3x squared minus 5x equals 0. What kind of equation is this? Quadratic. It helps to know what the equations you're dealing with. And so if I'm solving this quadratic equation, so if I cover the right-hand side, on your test Tuesday, how will you factor the left side? Huh? GCF. What's the GCF? GCF is not 1. GCF is x. GCF is x. So I can factor this as x times what? Minus 5 equals 0. So you got to say equals 0. So now I have, how many factors are being multiplied together? 2. They are x and 3x minus 5. And according to the zero factor property, what do I do to those two factors? I said each one equals 0 because their product is 0. In order for their product to be 0, one of them has to be 0. So I said each one equal to 0. That's all I do. And then I solve these linear equations. Well, here, that's the easy one. There's nothing to do in this one because x is already by itself. What's x? 0. Over here, I add 5 to both sides. Combine like terms, I get 3x equal 5. And then to get x by itself, I'm going to have to divide both sides by 3. And so my other solution is 5/3. So on the blank, you could say x equals 0, comma, x equal 5/3. Number 6. Number 6, suppose you had x squared plus 3x minus 40 equals 0. All right. So you're going to solve this quadratic equation by factoring. So you're going to try to factor the left-hand side. What's the GCF? 1. So it's a trinomial, so I'm going to go directly to factoring as two binomials. Equals 0. Don't forget to say equals 0. What works? X. Okay, x plus 8, x minus 5, yes. And before you go any further, before you start using the zero factor property, make sure what you have is correct. Use the FOIL method, FOIL it out. But really, all you do, because you know the first is correct and the last is correct, you just got to check the out and the inner. What's the outer? Negative 5x. What's the inner? And what's 8x and the negative 5x? 3x. All right, now I can go further now. So I have a product that is 0. So how many factors do I see here? 2. X plus 8, and the other one's x minus 5. So in order to get a product of 0, x plus 8 has to equal 0, or x minus 5 has to equal 0. So again, notice I went from a quadratic equation to 2 linear. And for us, it will be 2 linear. In a future course, you could easily have an equation that ends up with something other than linear. All right, so when I saw this linear equation, what's x equal to? Negative 8. So there's one of my solutions. Over here, x equal what? 5. There's your other solution. All right, number 7. So number 7, suppose I had 2x squared plus x equal 3. 2x squared plus x equal 3. All right, so you're saying the GCF is x, okay? Now remember, what property do I want to end up using? Zero factor property. And the zero factor property says this. In order for me to use it, it says this. It says I have to have 2 or more factors, and that product has to be what? 0. So if I factor out an x here, that product's not going to be 0. It's going to be what? 3. So I can't use the zero factor property if that's the case. So what you got to do is this. You got to remember this. So it's new phrase, I guess. You got to put this in standard form. So in solving a quadratic equation, it's got to be in standard form. And so standard form means this. It looks like this. Ax squared plus bx plus c equals 0. See the zeros on the other side. So it makes all you do is bring everything to one side, and what's going to be on the other? 0. So you got to bring that 3 over, right? So really what you're doing is subtracting 3 from both sides. And so when I do that, I get 2x squared plus x minus 3 equal 0. So now I will be able to use the zero factor property. But I got to factor this trinomial, this quadratic trinomial.
So basically, when we get our test, you just don't give us problems like these, and we need to know what to do, basically.
Mm-hmm. Yep. So what's the GCF over here? 1. So I'm going to go since it's a trinomial, I'm going to go directly to the 2 binomials. At this point, your factoring practice needs to be paying off.
So you just
Huh?
subtracted 3.
I subtracted 3 from both sides. Yeah. Adding 3 is not going to help them because when I add 3, what's 3 plus 3 over here? 6. I still didn't get 0. So you got to subtract 3. All right, what's going to be your 2 binomials? 2x what?
And x.
Okay, 2x and x, I agree with that. What's going to be this binomial? Huh? 2x plus 3, you think? And what's this one? 2x minus 1? All right, let's check it. What's the outer? Negative 2x. What's the inner? 3x. What's 3x and a negative 2x? Positive x. So this works. Now can I use the zero factor property? Yeah, because I have a product that's equal to 0. So one of those factors has to be 0. So either 2x plus 3 equals 0 or x minus 1 equals 0. So again, I went from a quadratic to 2 linear. Over here, when I subtract 3 from both sides, I get 2x equal a negative 3. Then I divide both sides by 2. So one of my solutions is x equal what? Negative 3 halves. Over here, x minus 1 equals 0. What's the other solution? X what? No, not negative 1. X is what? Positive 1. So if for some of you may need to actually say plus 1, right? All right. Okay, one more, and then we're going to look at something else. All right, number 8. Suppose in number 8, I had this. All right, so again, now you know that, hey, I better make sure that this is in standard form. Is this in standard form? Yeah. Is there GCF other than 1 here? No, the GCF is what? 1. It is a trinomial, so let's go directly to the two binomials. Now, number 7 was easy because of this. If you look at A and C, they're both prime numbers. So when they're prime numbers, it's easy to deal with. Now this one, so 7, you should have factored 7 a lot quicker than you possibly would with number 8. Because in number 8, 8's not a prime number. But 3 is. 8's not a prime number. So it may take you a little bit longer to factor this. But remember what we did, our factoring strategies that we dealt with when we studied factoring. What do you think works?
4x plus 1.
Okay, 4x plus 1, and then what? 2x plus 3? All right, I just wrote what was stated. Always check. It's easy to check. It's very quick to check. 4x times 2x? 8x squared. Let's go to the last. A positive 1 times a positive 3? Positive 3. Now let's do the outer and the inner. What's the outer? 12x. 12x, right? What's the inner? What do we get when I add them up? 14x. So this is correct. And so we're almost done with this. So what's the next step? We use a zero factor property. And so basically you're going to take each of these factors. So if you have a product of 2 or more factors, then one of them has to be 0. So he said each one equal to 0. And notice I went from a quadratic equation to 2 linear. So it's just a matter of you solving these linear equations. So over here I get 4x equal negative 1. And divide both sides by 4. What's one of my solutions? Negative 1/4. Over here, to get the variable by itself, I'm going to have to subtract 3 from both sides. Combine like terms, I get 2x equals a negative 3. And then finally, I have to divide by 2. And so my other solution is a negative 3 halves. Okay? All right, now we're going to do more with factoring next time as well. So I got you far enough with this part to be able to do this worksheet. So we're not done. There's something else we got to look at. but I need for you to practice on this part of the factoring, solving equation by factoring before we look at the part 2 of solving equation by factoring.